today, just to remember what asymptotes are. Vertical asymptote. How to find a vertical asymptote, that's where your denominator is undefined. Where your denominator is undefined. Okay, that's where you'll always have a vertical asymptote. So just a quick example, if you have f of x equals 1 over x minus 2, where is your denominator undefined? Pretty much where is your denominator equal to 0 in a fraction? 2, so you would say I have a vertical asymptote at x equals 2. We did this last year in pre-calc. I mean, this should be easy. You just always, whatever the denominator is, set it equal to 0, set it equal to 0. If it cancels with something in the top, that's called a hole. That's not an asymptote, that's a hole. Okay, so if it cancels with something on top, that's a hole. If it doesn't cancel out, like this one doesn't cancel out, that's your asymptote, your vertical asymptote. Could you have more than one vertical asymptote? Yeah. Yes. Could you have no vertical asymptotes? You sure can. Think of a parabola has no asymptotes. Okay, so again, you could end up having a number, you could have no asymptotes for that one, or you could have something canceling it out and it being a hole in the graph. That's all it would be. It's not necessarily an asymptote, just a hole. Now, horizontal asymptotes, there's only 3 types that it can possibly be. And we learned this last year in pre-calc. Your 3 types are, you could have y equals 0, none, or the coefficient. And it's the same thing here. Your answers tonight for horizontal asymptote are all going to be the same. It's going to be none, it's going to be y equals 0, or it's going to be a coefficient. Well, here's how the calculus merges with what you learned last year. If you take the limit as x goes to infinity of the function, whatever that happens to be, let's say it's 3, okay? Or you take the limit as x goes to negative infinity of the function, then the line y equals L is the horizontal asymptote. And I'll give you an example, just write it down. You can just take, if they give you a function, which they're going to give you tonight homework, if you just take the limit as x goes to infinity of that function and do a limits on it, you can figure out what the horizontal asymptote is. You can remember, though, from last year. I did a foldable last year. Amy Davis was all proud of me. She's like, look at that foldable. I was like, I know. It's a good foldable. But if I give you a function, 5 minus 2 over x squared, let's say that, okay? And I say, okay, find the horizontal asymptote. Actually, just write, what is the horizontal asymptote? Something like that, okay? I don't know what, the directions will say something along those lines, or it'll actually say, use limits to find the horizontal asymptote. So here's what I'm asking you then. Take the limit as x goes to infinity of 5 over 2 minus x squared. And if you recall limits, my SBCCers do because they have to do that last test there, you are allowed to separate limits. You're allowed to go the limit as x goes to infinity of 5 minus the limit as x goes to infinity of 2 over x squared. What is the limit as x goes to infinity of 5? What is it going to be?
5.
Not derivatives, limits, 5. The limit of a constant is the constant. The limit of the constant is the constant. What's the limit, we've done this before, as x goes to infinity of an x in the bottom? Do you remember that little rule? If you don't, we'll write it down. The limit as x goes to a positive or negative infinity of 1 over x, what does that equal? 0. Let's think of it logically. 1 over 100, 1 over 1,000. Isn't that number getting tinier and tinier and tinier? 1 over 1,000,000. Wouldn't that be a very tiny, 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 tiny number? It's approaching 0. 1 over negative 1,000,000, 1 over negative 1,000. Doesn't matter. It's approaching 0. It's getting very, 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 very tiny. Okay? That's the trick thing we're going to use with, in a minute. So then what's my limit now? 5 minus 0 is? That is your horizontal asymptote. Okay. Now, you do have to check the limit of this as x goes to negative infinity also. But it's the same, to be honest with you, it's going to be the same exact thing as before. You're going to end up with 5. Okay? And you could also look at this picture, just so you know. This picture, I don't know if you even remember your pre-calculus skills. 1, 2, 3, 4, 5. Do you know what an x squared looks like? X squared is a volcano. It usually shoots up like this, the volcano shape. So a negative x squared would flip upside down, and it would shift up 5. And there's your horizontal asymptote. So you could obviously look in the calculator. But this is how it applies. So limits, as we go to infinity or negative infinity, are horizontal asymptotes. Wow. You're impressed, aren't you? No. Okay. What? 5 minus 0. The limit of 5 is 5. I know. This is going to be hard because you're going to try to do derivatives, but don't do derivative. We're talking about limits. We're switching it up today for a reason. All right. And just to go over, again, what more of your homework will be like, determine end behavior and limits. So,
from last year.
yeah, it will always be my new buddy. Okay. So just real quick, all I want you to do is determine the asymptotes, the horizontal asymptote for this one. I don't know if the directions will even ask for vertical. They might on one of them, but not even. But vertical is pretty easy. Just set your denominator equal to 0. But for limits of infinity and determining the end behavior, like where are they approaching, you just look for the horizontal asymptote. What did we learn is the trick for rational expressions? What do I do to the top and the bottom? Divide everything by the highest degree. So divide by x, divide by x, divide by x, divide by x. What is, if you have an x in the denominator, this is what this limit rule says. As x goes to infinity, if you have an x in the denominator, or negative infinity, it goes to 0. So this guy goes to 0. This guy goes to 0. But what does this front one go to? 3. The limit goes to 3. What does this bottom one go to?
2.
So where does this entire limit go to?
3.
That is your horizontal limit. Horizontal asymptote. Y equals 3/2. Boom. All right, do the same thing to this one. Divide, 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 divide by the highest degree. Divide, 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 divide. If it has an x in the bottom, it goes to 0. If it reduces, reduce it. Everything on top goes to what? 0. But what does the bottom go to?
4.
Are you allowed to have 0 over 4?
Yep.
What is 0 over 4?
0.
That is your horizontal asymptote. Remember, I told you there's only 3 things it can be. It can be a coefficient, y can equal 0, or this last one. If I divide everything by x squared, now I have 3 over 0. Is that allowed?
No.
No. What do you think then my horizontal asymptote is? None. I would say horizontal asymptote, none, Mrs. Seta. But you do have to find something else that you may not remember from last year. Yes, John. If your top is bigger than your bottom by 1 degree, the top is bigger than the bottom by 1, you have what's called a slant asymptote. Do you remember how to find the slant asymptote? Long division. So I will do this for you. I think you only have one of these problems tonight, long division. It's warm in here. Long division is very easy for slant asymptotes. Slant asymptotes are only y equals mx plus b. That's all they're ever going to look like. So you should have an mx plus b. That's it. Something x plus b, or just something x. It could be that. And here's how you do long division. How does an x become a 3x squared? What do you need? 3x. Take that 3x, multiply, and multiply. So 3x times x, 3x squared. 3x times 2, 6x. change a sign, because these got to cancel. The front's got to cancel. Change a sign, change a sign. What is 4x minus 6x, though, make? Okay, and now do it again one more time. How does an x become a negative 2x? What do I need? See how that's already in y equals mx plus b form? Don't even find the remainder. Don't do anything else. That's your slant asymptote. Y equals 3x minus 2. So you'll have like one of those, I think, tonight for homework, like where the degree is higher by 1. But most of the time, it's either going to be 0 or a coefficient. That's it, 0 or a coefficient. All right, 2 more, and then just 2 laws, and I'm done. These ones are actually more for my SPCCers, because they will see this. I know, sorry. You're exclusively awesome. The ones with square root. What? I know. I'm going to miss them.
He's going for the PGA Tour.
I know. No, I don't know. I'll be excited if you do. I'll be excited if you are. Brad watches golf. Okay. Couple things to recall, and this is going to trick you up, especially the second one. What's your highest degree in this one? Looks like x squared, right? But it's under a square root. Would you agree? Okay, so listen to what I'm about to do. I'm going to divide by the square root of x squared, square root of x squared, square root of x squared. There's a reason, there's a method to my madness. Just bear with me. Square root of x squared. Okay, what is the square root of x squared?
X.
You're wrong. It's plus or minus x. Why is that important? Because depending on what infinity you're going to, tells you if you're going to be a positive or negative. That's why. So here's what I mean. For this one, I'm going to positive infinity. Would you agree? Right? So x's are getting larger. So when I divide by the square root of x squared, I'm actually dividing by positive x. Minus 2 over positive x. On the bottom, since they're both underneath the same square root, okay, what does this reduce to? What would the square root of 4x squared over the square root of x reduce to? Square root of 4. And then what is this guy going to reduce to? Well, it doesn't matter. 5, square root of 5 over square root of x squared. But here's why I'm doing this, okay? So this on top, we'll go back up here, 3x over x goes to what? What's that limit go to? 3, right? X over x cancels. What's this limit going to go to? It has an x on the bottom. What's the limit of the square root of 4 go to? 2. What's the limit of 5 over the square root of x squared? What doesn't matter because it still has an x in the bottom? 0. So what is my limit for this one? What's that horizontal asymptote? 3/2.
Why isn't it plus or minus?
Why is this not plus or minus 2? Because I've already taken the plus or minus with the x squared. So it's positive. It's going to positive infinity. X is getting more and more bigger, not getting more and more negative. However, that changes with this one. Okay? That's why I'm showing you 2 different ones. This is going to negative infinity. That means, here's the only thing that's going to change is your x that comes out of the square root of x squared is a negative x. So, for example, if you're like this, you're like, okay, square root of 3x squared divided by the square root of x squared plus the square root of 4 divided by the square root of x squared. If you're doing it like this, x over the square root of x squared plus 6 over the square root of x squared, okay? Anything that has an x on the bottom goes to where, everybody? 0. So let's just make him go to 0. Let's make this go to 0. Yes? Okay, now let's talk about these two. Square root of 3x squared over the square root of x squared, where's that going to go to? Where's that going to go to? What does that reduce to?
3.
Try again. Square root of 3. This guy is our trick problem down here. Because again, since we're going to negative infinity, when you take this square root out of x squared, it's actually going to negative x. And x over negative x reduces to what? So the answer for this horizontal asymptote is negative square root of 3. It's the negative square root of 3. And that's only going to happen if you go to a negative infinity. That's it. So on homework tonight, if all your infinities are positive, yay, just do the tricks. But if one of them is negative with a square root, just double check. One of them is going to have to go to a negative. I know this is probably more theory for you. Bear with me. I don't even think you have a lot of problems like that tonight, but that's really more for my SP. X goes to negative infinity of e to the x. The limit of x goes to positive infinity of e to the x. And then we're going to flip that. The limit as x goes to negative infinity of 1 over e to the x. And as it goes to positive. And then this is it. We're just writing these. We're just going to talk about these and we're done. I just want to make, this is just going to help us with what we do in the future. And you'll be fine. This should make sense to you. Remember, limits are end behavior. We did end behavior last year. That's all it is. As x gets more and more bigger, what is my y values going toward? As x gets more and more smaller, what are my y values going toward? So let's look at the picture of e to the x for those who don't remember. It looks like this. So as x gets more and more largely negative, here's my x-axis, here's negative numbers, where is my end behavior headed toward? 0. The limit of x as x goes to negative infinity of e to the x is 0. What about when x gets more and more largely positive? What kind of y values am I getting? What are those y values? Positive. So where is it headed toward? Infinity. What if I flipped that? What if I now did 1 over e to the x? Well, 1 over e to the x looks like this. Y equals, I'll call it e to the negative x. What just happened to these two limits now? They flipped. That's all they did. So as x gets more and more largely negative, y's are getting more and more bigger. As x gets more and more largely positive, I'm approaching 0. Okay? That's going to help us for the future. That's all I want to